everyone, and welcome to section 1.2, which deals with using the language of algebra. So our goal today is to use variables, what are they, and symbols to simplify using order of operations, evaluate expressions, identify and combine like terms, and then translate an English phrase to an algebraic expression. So let's get started. So what is a variable? It's a letter that represents a number whose value can change depending on the situation. So some examples are X, Y, S, T, Z, and so on. And a constant is a number whose value always stays the same. So constants, you can just think of them. If you see a number, you can also call it a constant. Okay, because it's not going to change. 1.2 is 1.2 wherever we see it. All right, let's continue. There are 4 operations, as we all know, but it's good to go over this. We have addition, subtraction, multiplication, and division. So here are the symbols: addition, subtraction. Usually for multiplication, we use this little dot, or we use parentheses to indicate that they're next to each other. And then division, we can use, for division, you can use, this division symbol or a line. And then you can see, so see down here, there's different ways of expressing division. Okay, so when we use these operations on 2 numbers, and when we translate from symbols to English, we need to pay attention to the words of and. So let's say, for instance, we have the difference of 9 and 2 means to subtract 9 and 2, okay? And the product of 4 and 8 means to multiply 4 and 8. All right, and then the next symbol we need to cover is the equality symbol, which is the equal sign, as we know. Okay, now what's an inequality? So an inequality, it could be, here is less than, we have less than, greater than, less than or equal to, greater than or equal to, okay? So in this case, strict inequalities are A is less than B. See how A is to the left of B on the number line? And in this case, A is greater than B. Okay, so greater than. A is greater than B. When I was, a long time ago, we used to pretend that the inequality had like little teeth and it wants to eat the bigger one. It's like a little alligator teeth. I don't know. Maybe that helps. Maybe that doesn't. Okay. Oh, another thing that I want to say is if A is less than B, then B is greater than A, which makes sense, right? See how B is to the right of A, so B is greater than A. Okay, let's see here. So again, just to recap, does not equal means it's not equal. This line right here does not equal. Less than is just the inequality this way. Less than or equal to, it has a little line underneath. Okay, so remember that. And then strictly greater than is just that this caret going this way. And then greater than or equal to, it's the greater than symbol with a line underneath it. Okay, so let's go ahead and do some fun examples. So here for A, we have 17 is greater than, is less than. So 17 is less than or equal to, right? Equal to 26. And then for B, we have, so this is a problem. This is another problem. Let's see, wait, 17 minus 3. Oh, no, sorry. Here, this is this. Here, let me erase this. I'm sorry. Because they're close together. It's kind of like, I want to make sure that you can see the difference. Okay. So for B, we have 8 does not equal the difference of 17 and 3, or you can just say 17 minus 3. Okay, and then for C, we have 12 is greater than, and then we have the quotient, or 27 divided by 3. And then finally for D, we have the sum of y and 7, or we have y plus 7. Y plus 7 is less than 19. Okay? So just to start getting familiar with the terminology, we're kind of easing into it, it's, not stressful. Okay, let's get into grouping symbols. We have parentheses, brackets, or braces. So here's some examples of grouping symbols. So here, the difference of 14 and 18 is grouped together. Here we have brackets grouping all of this, and then within that we have this. So what we do is we're going to solve using PEMDAS, right? And I think we're going to get into that more in a minute. So I'm going to go ahead and keep going. Have a lot of slides to cover here. So what's an expression? We have a number, a variable, or a combination of numbers and variables using operation symbols. Okay, so remember operation symbols are plus, minus, multiplication, and division. Okay, so here's some examples of expression. 3 plus 5. Okay, the sum of 3 and 5. N minus 1, 6 times 7. X divided by y, or the quotient of x and y. So remember that multiplication is the product. N minus 1 is the difference of n and 1. And when we're adding, it's the sum of, okay? Now, an equation is basically an expression, two expressions, where an equal sign connects the two expressions, okay? So how we would say this, we have 3 plus 5 is equal to 8 in words, but the sentence would be the sum of 3 and 5 is equal to 8, right? So the sum of 3 and 5, that's 3 plus 5 here, is equal to, that's the equal sign, and then 8 is over here, okay? And then here, n minus 1 equals 14. So n minus 1 equals 14. The product of 6 and 7, so 6 times 7, is equal to, right, 42. X is equal to 53, so x equals 53. And then y plus 9 is equal to 2y minus 3. So y plus 9 is equal to 2y minus 3, 2y minus 3. Okay, so it's very easy to tell if something is an expression or equation. And basically you ask yourself, how to tell if there's an expression or an equation in front of you. Is there an equal sign? Okay, so let's see. For A, we have 2 times x plus, the sum of x plus 3, x and 3 is equal to 10. So this is an equation. Okay, here we have 4 times the quantity y minus 1 plus 1, but there's no equal sign, so this is an expression. Okay, here x divided by 25 is also an expression because there's no equal sign. Okay. Here we see the equal sign. Okay, fine, that's an equation. Okie dokie, let's do some examples. Determine if each is an expression or equation. So take 10 seconds and, see if you can either say it with me or write this down. It's up to you, whatever. If you need to write something down, go ahead and push pause on the video and then you can write it down. And then we can talk about the answers. Or if you just like to go through it with me, go through it with me. Okay, so for A, is this expression or equation? It's an equation, right? There's an equal sign. B, expression or equation. Is there an equal sign? No. So it's an expression. How about this guy? For C, x divided by 25. There is no equal sign, so it's an expression. Okay, and then here, there is an equal sign, so that's an equation. All right, cool. Let's continue. Exponential notation. So a to the power n means to multiply a by itself n times. Okay, so this is the base. So you have a to the power n. This is the base. Okay, and this is the power or the exponent. So we can say exponent. All right, so we say a to the nth power. So here, 7 squared is usually how we say it when there's a second power, 7 squared. When it's a third power, we say cubed usually. Okay, and then after that, we say 4th, 5th, 6th, 7th, what have you. 9 to the 4th power, 12 to the 5th power. So if we want to simplify 3 to the 4th power, what that really is, let's look at this super fun example. It's just 3 multiplied by itself 4 times, okay? So that ends up being 9 times 9, 81. Okay, not too bad. Not too bad. Okay, so let's simplify expressions using the order of operations. Okay, so to simplify expression, we need to do all the math. That means that if we have like multiplication, division, and then we, we need to come up with the most simplified way possible. That means we can't add anymore, we can't multiply anymore. We get it in what's called the simplified form. So let's say here we have 4 times 2 plus 1. We have to multiply 4 times 2 first and then add 1, and that's 9, okay? So basically, to simplify an expression, we need to do all the operations in that expression. So let's talk about order of operations. Step 1, we do parentheses and other grouping symbols, right? So we basically look for parentheses and then simplify everything inside of it. Step 2, exponents. So exponents. Step 3, we do multiplication and division going from left to right. And then addition, subtraction is at the end. So that's the order in which when we look at an expression that we simplify. And we call that PEMDAS. A lot of common things is called PEMDAS. Sometimes we say GEMDAS. But the thing about using PEMDAS is you can say, please excuse my dear Aunt Sally, if you forget, oh, which do I do first? If you see an equation on the street or you see an expression, somewhere when you're walking down the street and you're like, well, which one do I do first? Do I do the addition part first or the multiplication part first? Well, you just have to say, okay, remember PEMDAS, please excuse my dear Aunt Sally. First stop is to look for any grouping symbols or like parentheses. Okay, solve those. Okay, now are there any exponents? Okay, do that. And then now, is there any multiplication or division? They're kind of on the same going from left to right, multiplication, division. Okay, solve those and then do the addition and you're done. So let's do super fun example, of course. So A, we have 4 plus 3 times 7. So don't forget, please excuse my dear Aunt Sally. Okay, so for A, there is no parentheses. Sorry about that. It does this. Okay. There is no parenthesis, but I do see that 3 times 7 is first. So you would first do 3 times 7. So this would be 4 plus 21, which is equal to 25. Okay. All right. So then for B, we have, I'll just write it out here again. 4 plus 3 times 7. But remember, it's PEMDAS, so parentheses first. So we're going to do this first inside the parenthesis, which is just 4 plus 3. That's 7. And then times 7. So that's going to be 49. Okay. So let's continue. Let's do another one. We have 12 minus 5 times 2. Okay. So which one are we going to do first? Remember, please excuse my dear Aunt Sally. We're going to do multiplication first. Yes. Okay, good. So then 5 times 2 is 10. And then 12 minus 10 is 2 today. So that's our answer. Okay. Oh, another thing you might like to get in the habit of doing is boxing your answers. It looks very nice. Okay, so B, we have 12 minus 5 times 2. Parentheses first. Okay, so 12 minus 5 is 7 today. Bring that down times 2. 7 times 2 is just 14. So notice that I'm going line by line, okay? That's super helpful. Just to keep your work, Okay, so when you have a lot of grouping symbols, you simplify the innermost parentheses first, and then you work outwards. So let's say here we have 5, I'm going to rewrite this, 5 plus 2 cubed plus 3 times, this whole thing, 6 minus 3 times the quantity 4 minus 2, or the difference of 4 and 2. So PEMDAS, right? Please excuse my dear Aunt Sally. PEMDAS, parentheses first. Okay, I noticed these, but inside of these, it's like a whole other, it's like another little tiny mini problem. So what you do is when you see this, you go, okay, this is 6 minus 3 times 4 minus 2. So what do I do first? I'm going to do this parenthesis first, okay? So you kind of look at it as I'm looking inside the brackets. That's a new little mini problem, okay? So what I recommend is write everything else out that's not going to be, that you're not going to work on. So write everything else exactly the way it is. So notice I wrote it out exactly. Now I'm going to do this. I have 6 minus, I'm going to 3, and then 4 minus 2 is 2 today, okay? So first thing I did was the parenthesis, okay? So now I have 6 minus 3 times 2, so I'm going to multiply 3 and 2 first, okay? Because that comes first before subtraction. So everything else comes down, okay? And then I have 6 minus 6, okay? That becomes 0, so everything else comes down. 3 times 0, then anything times 0 is just 0. So then I get 5 plus 2 cubed plus 0. So, it doesn't matter. I don't need to keep writing it. 2 cubed, now that's next because that's exponent. So 5 plus 2 cubed, 2 times 2 times 2 is 8. So that's just 5 plus 8, which ultimately becomes what? 13. That's your final answer. Okay. Now, the question becomes, well, do I need to keep writing down every single line? You don't. No. Once you get good at this and you practice this a lot, you don't have to keep writing every single thing. But if you're starting out and if you're like a lot of people that are taking this class, this isn't everybody, but some of you are coming back to school after a long period of time. Some of you are starting over. Take that time. Make it count, write everything out, it's okay. It only takes a couple seconds. Train yourself to do that, and then you'll be glad that you did. Because you'll be right, Okay. All right, let's go over evaluating an expression. What does it mean to evaluate an expression? Okay, so it means to find the value of expression when the variable is replaced by a given number. Okay, let me tell you in English, right? What does that mean? Okay, that means you're given an expression, and then you're given the value for the variable, you just plug it in. So in other words, plug in, right? That's an easier way to say that. So let's see here. We have 7x minus 4. Let's evaluate 7x minus 4 when x is equal to 5, okay? So what that means is you're going to do 7, and instead of an x, so the best way is to plug in, use parentheses. Okay, so 7 times the quantity, well, times just 5, sorry, not the quantity 5. So minus 4, okay? So all I did was I took, you tell me that x is equal to 5, so I'm going to take it and I'm going to plug it into the expression. So 7 times 5 minus 4, that's 35 minus 4, that's just 31. Okay, let's try the next one. We have x is equal to 1, so same expression, but now instead of 5, I'm going to put in 1. Okay, so 7 times, because they're right next to each other, that indicates multiplication. So that becomes 7 minus 4, which is just 3. Okay, all right. Now let's go ahead and do the next one down here. We have evaluate x equals 4 when x squared and b is equal to 3x. So first we're going to plug in, we have x squared. So then that's going to, if x is equal to 4, that means 4 squared, which is 16. And then you have 3 to the power x, which is just x is equal to 4. You have 3 to the power 4. That's just going to be 3 times 3 times 3 times 3. We did that earlier, so that's 81. Okay, let's combine like terms. Okay, let's talk about like terms. What are like terms? Well, think about the name. Okay, so mathematicians were not super creative, okay? Well, with exceptions, but for the most part, math is very straight up. What you see is what you get. And that's what I love about math. The names are exactly what they are. They're not trying to trick you. It's just what it is. Okay, so first of all, let's define what a term is. Okay, a term is a constant. Remember that a constant is a number, right? Or the product of a constant and a variable, one or more variables. So some examples are 7y, 5x squared, 9a, b to the 5th, 10xyz. So notice that there's no pluses and there's no minuses. in a term. Another word for this, it's called a monomial because it's just one term, right? Okay, so we'll see that later. Now, if you have a constant in your term, that constant has a special name. It's called the coefficient. So let's say here, for example, you have 5x. Your term is 5x. What's your coefficient? Your coefficient is just 5. Okay, so let's say if you have 10x, 10y, whatever, who cares? Who cares what the variable is, okay? What's your coefficient? Your coefficient is 10 only. When I say what's the coefficient, that means what's the number that's in front of the term, okay? How many of that variable are there, okay? So again, so coefficient is the constant or the number that multiplies the letter, okay? All right, let's do this. So here we have identify the coefficient of each term. Now, this is fun, okay? So now go ahead, if you want to try this on your own, hit pause and then, then go over the solutions. Otherwise, if you just want to go through this with me, let's go through this together, okay? So A, we have 14y. What's the coefficient? If you said 14, yay, good for you. B, we have 15x squared. So what's the coefficient? The coefficient is just 15. Now, interesting one, we have, for C, the letter A. Well, wait a second. I don't see a coefficient at all. I don't see anything. Well, you might be interested in finding out that any letter that's by itself it's assumed to have a 1 in front of it, okay? So anytime that you see an X by itself or a Y by itself, you can think to yourself, oh, that's 1X, okay? We don't write it because it's kind of like, mathematicians are lazy. If they can get away with writing less, they will. So that's why, we just don't need to write it. So this coefficient for the letter A is just 1, okay? It's invisible, but it's there. Just kind of like, I don't know, like in Spanish, the silent H. It's invisible. You don't say it, but it's there, Okay, so let's see here. Some terms share common traits. Let's look at these terms which seem to have traits in common. Okay, well, basically, we're looking for terms that have the same type of variable. Okay, let me just, so look at here. We have a 5x, a 7n squared, 4, 3x, and a 9n squared. So here you notice that the 5x and the 3x are similar terms. Okay, the coefficients are different, but the variables are the same. Okay, so 7 and 4 do not have any variables. Okay, they're constants, but they're still alike, right? And then finally, we have the n squared and the 9n squared, and those two are in common. Okay, so we would say that that's where this term, that's where the saying like terms comes in, because there are terms that have the same variable. Okay, so really not, it's really important that you guys understand that because we're going to be using them a lot. So 7 and 4 are like terms, 3x and 5x are like terms, x squared and 9x, x squared and 9x squared, n squared, and 9n squared are like terms. This is a typo in the book. So, yes, x squared and 9 squared are like terms, but okay, so terms that are either constants or have the same variables raised to the same powers, oh, that's important, are called like terms. So let's say you have 3x, 5x squared. These are not like terms. Why? Because x and x squared are different, are considered different. Okay? All right, so let's identify the like terms here, okay? So let's see here, we have y cubed, 7x squared, 14, 23, 4y cubed, 9x, and 5x squared. So what are the like terms? Okay, well, we have y cubed and we have 4y cubed, okay? Okay, we have 7x squared, and then no, yes, okay? So 5x squared is like, okay? Then we have 14, sorry, ignore that little box thing, that's just my hand, and 23, okay? Those are alike. And then 9x squared, you don't have it. 9x, you don't have any, it doesn't have any friends with it. Okay, so we just leave them alone. Adding or subtracting terms forms an expression. Yes, it does, right? So here we have an expression 2x squared plus 3x plus 8. We have one term, another term, another term. So 3 terms. Terms are separated by pluses or minuses in an expression, okay? So that's how you know which, you're like, well, which ones are my terms? Well, you look at the pluses and minuses in the expression, and whatever is in between them, that's your term. That's a term. Okay, so let's identify the terms in each expression here. So for A, what are your terms? Okay, so for A, the 3 terms are 9x squared, that's one of them. 7x is the other one. 12 is another one. Okay, not too bad, right? Can you do this one? Okay, so for this one, we have 8x plus 3y. So what are my terms? I have 8x and 3y, and that's it. Good job. Okay, so how do I combine like terms? Okay, so first, step 1, we identify them. Okay, step 2, we rearrange the expressions so the terms are together. And 3, we add or subtract the coefficients, and we keep the same variable for each group of like terms. Now, this step 2 is optional because some people can do it without rearranging and some people can't. So it's up to you, really. So let's say here we have, okay, let's identify. So we have 3x squared plus 7x plus 9 plus 7x squared. Okay, I'm going to underline that. Plus 9x plus 8. So then I have the 7x is alike with 9x, okay? And then I have the constant 9, and its partner is over there, okay? So what you can do, so this is step 1, that's identify. Step 2, rearrange them, that's fine. If this helps you, do it. If it doesn't, then don't, it's okay. No one's going to hold you accountable in that way. It's all right. I mean, I want you to write everything out. You know why? Because that way when you look back and you're like, what did I do? You can see what you did. Okay, so now look how I rewrote the expression. I put the like terms together. I have 3x squared plus 7x squared. So what do you think 3x squared and 7x squared is? Their coefficients are what tell me to add or subtract. So it's a positive 3, positive 7. Together they make 10, you guessed it, 10x squared. Okay? Then I have here 7x plus 9x. So think of it as I have 7 apples plus 9 apples. Together I have 16 apples, or 16x, okay? And then finally plus, because this is positive 9 plus 8, that's 17, okay? So that's that. So see how we did that? Wasn't too bad. All right, so let's do this again. So this is part 3, I guess. So number 1, identify the like terms. This guy and this guy, okay? The y's, go with the y's, and then the constants, go with the constants. Okay, notice that I did, I'm using different types of underlining, but you could do box, you could do circle, you could do triangle, you could do whatever you want, as long as you distinguish between the terms, okay? So that's step 1, check. Step 2, let's rewrite it. Okay, fine, 4y squared plus 8y squared plus 5y plus 4y plus 2 plus 5, okay? All right, so here we have 4y squared plus 8y squared, that's 12y squared, plus 9y plus 7. So see, I did these two, and then these two. And that's it. That's our answer. We simplified it. We combined like terms. Okay, so then finally, we're almost done, you guys. You're doing great. We have, let's go over the operations. Addition, subtraction, multiplication, division. Okay, we have for addition, a plus b, the sum of a plus b, a increased by, more than, the total, and added. For subtraction, the words that you might see in a word problem, minus, the difference of, decreased by, less than, b less than a. Notice the order here, a decreased by b, right? When you say b less than a, notice that it flips order. This is a minus b. Less than means to put it in behind it. And subtracted from, that's another one, right? So see how b is first, but when you write it down symbolically, it goes after the minus sign. So there you go. That's the only thing that's kind of, okay, I have to remember. Multiplication is times, product, and here's an example, twice a, 3 times a. Division, the words are divided by, quotient, ratio, divided into, okay? All right, so let's translate this. Let's use these, okay? So sum of A plus B, difference, product, quotient. So for A, let's go ahead and do the difference of 17x and 5. So that would be the difference of 17x and 5. That's it. B, the quotient of 10x squared and 7. 10x squared and 7. That's it. Okay, not too bad. Quotient means divide. All right, let's do another one. Translate this. 17 more than y. Okay, so what is that? So A, 17 more than y, so y plus 17. B, 9 less than 9x squared. So 9x squared minus 9. Remember that it's less than. Less than means it goes after. Okay, so let's do a couple more because this is important. A, we have 11 more than x. Okay, fine, x plus 11. B, 14 less than 11a. You guessed it, 11a minus 14. Okay, it's a less than again. All right, so we have here the difference of 2 times x and 8. So 2x and 8, that's the difference, minus. And then B, 2 times the difference. Now, when it says the difference of x and 8, it's like this, okay? And if we want to multiply that, we want to do that 2 times, so that's why we need parentheses, okay? All right. Okay, so let's do a couple more. The length of a rectangle is 6 less than the width. So length of the rectangle is 6 less than the width. Let W represent width. And then let's express, this is the expression for the length. So the length can be expressed as, W minus 6. Okay. The width of a rectangle is 6 less than the length. Let L represent the length. And we need to say the width is 6 less than the length. So the width is 6 less than L. Okay. So that's another way. I wrote it as an equation because I use this sentence here and that has an is, so that's an equal. But if you just wanted to write the expression, you would just write L minus 6, okay? All right, let's see here. June has dimes and quarters in her purse. The number of dimes is 3 less than 4 times the number of quarters. Q is quarters. It says the number of dimes is 3 less than 4 times the number of quarters. So dimes is, so when I see is, I put an equal sign, but it's fine. You can write the equal sign, but in this case, because it asks you for an expression, you don't write the equal sign. You would just say, 3 less than 4 times the number of quarters. So that's 4Q minus 3, okay? But I actually won't, like if you do your homework and you write D equals, or dimes equals 4Q minus 3 like that, I'm fine with that. I'm fine. It's fine. Okay, so Jeffrey has dimes and quarters in his pocket. Q represents the number of quarters. Now the number of dimes is 8 less than 4 times the number of quarters. So that's dimes. So dimes. You can write it like that if you want. Okay, so the number of dimes is 3 more than 7 times the number of nickels. N is nickels. Nickels, okay. And then dimes, what's the phrase for dimes? 3 more than 7 times N, which is nickels, okay. All right, so that's it for 1.2. Your super fun homework, every other odd, 83 to 175, because yes, that's a lot. So what we do is, you know how the odds go 83, 85, 87, 89, and so on. So every other odd. So you would start this, skip this one, then do 87, skip the next one, then do 91, and so on. So that's every other odd, okay? All right, good luck, and I will see you in the next video, or hear you, right? All right, bye. Good luck.